So far, we've done 2 sections. We've got 2 more we'll do this week. So let's do a quick refresher. 2.1, which was the first lesson I taught you guys. What was that about? Slope-intercept form. What is slope-intercept form? Y equals mx plus b. If you see an equation that's in this form, what's the graph going to look like? These are lines, right? Everything we're doing in this section, or this chapter, is all about graphing lines. I've not really said that yet, but here's how you know you'll be graphing a line. If you just have an x and a y, and they're both raised to the first power. You guys know what that means? Exponent. You know what an exponent is? Yes. And so you can't see an exponent here, right? Which means we understand it's to the first power. It's just like if I just have a variable like x, there's an understood 1 in front of it. Same thing, if you don't see an exponent, it's understood to be the first power. All right, tell me what else you know about slope-intercept form. It's y equals mx plus b. It graphs the line. What does the m represent? What's the b represent? And then what's x and y? It's any point that's on the line. Okay, and then one of these things was more important than the other. Well, they're all important. But we focused on what slope is. So just a little side quest. What is slope? Rise over run. Could also say it's the change in y over change in x. Right, delta y over delta x. What's the slope formula? Is everyone okay with that? All that stuff? Just like giving a refresher. Make sure we still remember. All right, 2.2. Does anyone remember what that lesson was on?
Was that when it gave us the line on the graph paper?
It could have been either one. Given the line, we had problems like that in both of them. It was about a different form. What does point slope form look like? So we need to get to learning that one, right? Seems like we don't remember that one. Y minus y1 equals m times x minus x1. If you see something like this, it also graphs a line, right? Notice I have an x and a y. They're to the first power. Anytime that's the case, it's going to graph a line. In this problem, m represents the slope, and x1, y1 is any point on the line. So when you don't know the y-intercept, this is a better form to use. What was the thing that you guys messed up the most probably on this homework problem? The fourth period messed it up more than you did, and I mean that. I say that because they asked me more questions, so maybe y'all messed it up the same amount of times. You just didn't ask as much. but people kept forgetting there's an understood negative or there's a negative in the formula, right? So if I had something like this, y minus 3 equals 2 times x plus 4. What's the slope of this line? Everybody's good with that. And then what was the point? -4, +3. Right? It's the opposite sign from what you see because there's a built-in negative in the form. B, which is going to be about standard form. Okay, and this will be the last form for a line that we look at. So standard form is ax plus by equals c. So again, notice, do I have an x and a y? Are they both to the first power? So if I graph this, it's going to be a line. Anytime you have an x and a y, both to the first power, it's going to be a line. Just looking at it, what do you notice is different about standard form compared to the other forms?
It has a A and B in it.
Has an A and a B and a C. Okay, right? It's on the other side. That's kind of different. We don't have an A or a C in any other form. In slope-intercept form, there was a B. Right? What did the B represent in slope-intercept form?
The
No, the
Y-intercept.
The B is the y-intercept. So is the B here the y-intercept? No, it's not. Okay. So don't think that that's the case. This is just some arbitrary A, B, and C. You know what arbitrary means? Just these A, B's, and C's don't really mean anything. Okay? They could just be any value. Standard form is not great for graphing. Right? I'm not going to put something in standard form if I want to graph it, or if I look at a graph, it's not easy to give the standard form. That's not its main purpose. Standard form is useful for finding an equation of a line when given a word problem. So that's mainly where our focus will be in this section. We will do a little bit of graphing. But it's not great. That's again, not great at graphing when this is the case. All right, some of the rules for standard form. A, B, and C must be integers. That's the first time I've used that word. You guys know what an integer is? True. I need a more strict definition. It is a number. Because not all numbers are integers. Can you give me a number that's not an integer? Or one that is?
Repeating decimal.
Okay, repeating decimals are not integers. That's true. Was somebody saying something before? Anybody else know a number that is an integer versus is not? 1 is an integer or is not? 1 is an integer. That's true.
They are negative numbers, integers?
Some of them, not all of them. Some, not all. Give me an example of one you think is.
I don't know, I was wondering if we already said decimals aren't integers, but can -1 and -2, is that an integer?
Those are. Those are both integers. Anybody want to give a shot in the dark? What the definition of an integer is? That's okay. I'll write it. An integer is just a whole number. You guys know what a whole number is? And their opposites. So what does that mean by opposite? Like their negative version. So 5 and -5 are integers. 8 and -8 are integers. So what's not an integer? Any decimal, any fraction, any mixed number. Make me vomit. Okay? It's just a fraction. Everybody good with that? So A, B, and C must be integers. Again, back to our rules. There's one more rule. A has to be greater than 0. Maybe it's greater than or equal to. Let's go with that. Let's go with A has to be greater than or equal to 0. What does that mean?
Can't be a negative.
Can't be negative. So really, B and C can be positive or negative whole numbers, but A has to be a positive. It is only a whole number, not an integer. But we just technically say they're all integers where A is a positive integer. Form. Hannah's going to spend $150 on music festival tickets. Reserved seat tickets cost $25 and general admission tickets cost $10. How can you represent the situation with a linear equation? All right? I just got to get a gauge of how you're feeling. Like when you see this problem, how does it make you feel?
Not good.
And why is that?
No.
Do you feel bad about every math problem? Partly, some people yes.
I like work.
I know, and you're not the only one. That's why I'm wanting that to be known. That the feeling of intimidation, I don't know if that's the right word, or dread, or oh gosh, whatever, is very normal. We don't want to make it, we want to make it normal to not be intimidated. No, you don't like Alabama's football team. So if I look at this problem, we need to start by identifying our unknowns. That's step one. What are our unknowns? Or more simply, what do we not know? So read the situation again and think about what things you don't know. Don't worry about the question at the end. Just that, till I drew that little box. So what's something that you think you'll need to be able to work a math problem with this, but you don't know.
How many tickets?
Almost great. That's a good answer.
How many reserved, like, seat tickets and just admission tickets?
That's the answer I'm looking for. There are two things I don't know. They both involve the number of tickets bought, but one of them is, I don't know how many reserved ticket seats were bought. I don't know how many general admission seats were bought. So those are going to be my unknowns. So I don't know the number of reserved tickets, and I don't know the number of general admission tickets. So what do we do in math when we have something we don't know? Or in computer science, something that can change? We create variables for these situations. So let one be X and one be Y. Does it matter which one's which? No, doesn't matter. Is everybody okay with that? That's step one whenever you get a word problem like this. Identify my unknowns. Okay. So I'm trying to come up with a situation that I can make an equation. What's an equation? Math statement with an equal sign. Something has to equal something in this situation. All right, let me ask this, because I think this is probably the way your brains have thought. Have you thought of any possible answers for like what Hannah could have done? Like, have you figured out at least when I was in your shoes, that would have been the first things I would have done. I've like figured out what are some things she could have that could make this work. Is essentially what I'm saying. Anybody have one? Or did y'all not do that yet? Okay, so what do I know about the situation? She spent $150. So I would have said, well, she could have bought 15 general admission tickets. And that'd be it. Right? That would be $150 spent, $10 each on 15 tickets. Anybody got a different answer that could work? Yeah?
6 reserved.
Could have bought 6 reserve tickets, and that'd be it. Okay? Anybody got a different one?
2 reserved and 8 general admission.
Close.
10.
2 reserve seats and 10 general admission seats would have gotten us to 150. So you guys, by doing this, you are using an equation that you have made in your heads. How are you finding this value to be true? Like, how are you coming up with these situations? You're taking the cost per ticket and doing what with it? Multiplying it by
The amount of tickets.
That's correct. So, if we were looking at reserve seats, this is the number of reserve seats I got. I multiplied this value by 25. Because, like we said, you could have 6 reserve seats. So somebody did 6 times 25 is 150. That was my total. Or we could take the number of general admission tickets, multiply it by 10. See where I'm getting these terms from? 25x and 10y. Now can you take all of this and put it into an equation, maybe? Here it is. 25x plus 10y equals 150. Think about what each term represents. This is the cost of a reserve ticket times the number of reserve tickets that I got. So this is the money, this whole term together is the money spent on reserve tickets. If I got 2 reserve tickets, that would be 25 times 2, which is 50 here. If I got 6 reserve tickets, 25 times 6 is 150. So this term represents the money spent on a reserve ticket. This term represents the money spent on a general admission ticket. And I know if I add those together, they have to equal 150 because that's how much Hannah's going to spend. How do we feel about that equation? Is that still not good? Still no eye contact. Okay, great. Fantastic. That's what I was looking for. She didn't have $40 to spend anymore. She had $60 to spend. Write that equation. The way they teach you to graph it is to graph the intercepts. Intercepts. I ran out of space. I don't want to deal with it. Okay. Graph the intercepts. What are intercepts? What's the y-intercept?
Where it crosses the y-axis.
Right. The y-intercept is where it crosses the y-axis. In geometry, did you learn through any 2 points there exists exactly one line? To make a line, I just need 2 points. The y-intercept is a point. They're going to tell you to find another point. And that point you find on the x-axis, which is the x-intercept. So you're going to find the x-intercept, the y-intercept, and then graph them. Did I tell you guys that this is not great for graphing?
Yes.
And it's not. So here we go. Let's first start by finding the, let's do the prettier one first. Let's find the x-intercept. So, sounds great. Thanks, Mr. Coots. How do you find that x-intercept? Yeah, good question. I want to do a little brainstorming. Sorry, I'm just going to tell you. That's not how it works. That's not how it works. Well, I think if you understand the process and you can fit into the big picture, you can do more math later instead of just memorizing all these steps that I told you. And then in the future, when I say, how do you find an x-intercept? You're like, I don't know. I have to look at my formula. I don't know formula. I don't understand. So think about where the x-intercept could be. The x-intercept could be here. Couldn't it? That's a spot. It could be here. It could be here. It could be anywhere on the x-axis. What is true of every point on the x-axis? Because I know the x-intercept has to be on the x-axis. Just give me a true statement about every point that is on the x-axis. Let's see, like here's a point, this is the point, 1, 0.
The x is 0. No, I mean, the y is 0.
Y'all buying that? If a point is on the x-axis, the y value is 0. You buying that? You buying that? So how do you find the x-intercept?
I still don't know.
You just put it on the three X.
To find x-intercept, plug in 0 for y. Because what are x and y? They're just any point that's on the line. But what if I know that I want the y coordinate of my point to be 0? I can just plug it in. 0 for y. That's going to give me 3x minus 2 times 0 equals 9. Negative 2 times 0 is 0. So 3x equals 9. So x equals 3. Which means when I plugged in 0 for y, I got 3 for x. Meaning the point 30 is on this line. There's a point. Any questions about how I did that? Finding the x-intercept. Sweet. Now, again, I told you I needed 2 points. So I found the x-intercept. Now let's find the y-intercept. How can I find the y-intercept? That's it. If it's a y-intercept, we know the x value has to be 0. Because every y-intercept is 0 comma something. So to find y-intercept, plug in 0 for x. So that would give me 3 times 0 minus 2 times y equals 9. Which tells me negative 2y equals 9. Divide by negative 2. And if I'm doing this part too fast, just tell me. Like if you don't follow that, I will get carried away and do that too fast sometimes. So when I plugged in 0 for x, I got negative 4.5 for y. So 1, 2, 3, 4.5. I found 2 points. Through any 2 points, there's only one line. There's that line. Is that great?